Hello everyone, in this tutorial video, I will be teaching you how to get the domain and range if the given are ordered pairs, table of values, mapping or arrow diagram, the graph, linear functions, quadratic functions, and rational functions. When we say domain, those are the possible inputs for our x-axis. And for range, those are the possible outputs for our y-axis. Now, what if the given are ordered pairs? Let's say our number 1. We have f is equal to our coordinates 1, 2, 2, 2, negative 3, 4, and negative 4, 6. We know that our coordinates is composed of x coordinate and y coordinate, or the abscissa and the ordinate. So x, y, x, y, x, y, x, y. Now let's find the domain and range of our given in number 1. Again, our domain are the possible inputs in our x-axis. So let us first get all our inputs in our x. Following our number line, we must start with the least number or the smallest number. In here, we have negative 4 followed by negative 3, then 1 and 2. These numbers are our domain. Now for our range, possible output for our y. So in our given, we have 2, 2, 4, 6. So we have 2, 4, 6. Next, what if the given is table of values? So we have here for our input x, we have 0, 1, 2, 3, and 4. And for y, we have negative 5, negative 4, negative 3, negative 2, and negative 1. In our table of values, we can write this as ordered pairs. If you want to write as ordered pairs, that can be 0, negative 5, next 1, negative 4, next 2, negative 3, next 3, negative 2, and 4, negative 1. Now let us find our domain and range. So it's okay if you're not going to write as ordered pairs. As you can see, we can get our domain by writing all our inputs in our x. So we have 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. And our y, we have negative 5, negative 4, negative 3, negative 2, negative 1. As simple as that. Next will be how to find the domain and range if the given is a mapping or arrow diagram. Example number 3, we have here our diagram. Let's say we have our input. We have the K, L, M, N. Then for the output, we have 1, 2, and 3. In this case, we can also write this as ordered pairs. So we can write this one as K, 1, next L, 1, M, 2, and lastly N, 3. Okay. And if you want, you can write your final answer. Just look in our diagram or mapping. We have, for the domain, we know that our domain is the input. So we have K, L, M, N. And for our range is our output values. So we have 1, 2, 3. As simple as that. We have the domain and range. Now let's have our problem number 4. We have our graph here. Notice our graph, studying our quadrants. We have quadrant 1, 2, 3, and 4. Now let's find our domain and range given this graph. So domain and range. But before that, take note that in finding the domain and range, if they given a graph, we can write our final answer using set notation. Set notation and interval notation. For the interval notation, later on you will encounter our shaded part or shaded region and the hollow region. Okay. So if you're going to encounter these two in our notation, for the shaded part, that means that number is included. We're going to use the bracket symbol, and if our graph is hollow, we're going to use the parentheses. Now let us first find the domain and range of our graph in number 4. Okay. Our domain, our possible inputs for the x-axis. This is our x-axis. Studying our x-axis and graph. Notice that our graph here can be extended through infinity. That means in our x-axis, so all numbers are possible. So for the domain, that is x, such that x is an element of real numbers. That would be our domain. Or in interval notation, that can be negative infinity to positive infinity. This is our interval notation. Why we use parentheses? Because we don't know where it ends. Next, range. Notice our y-axis. We know that range are the possible output for our y-axis. And studying our graph, the line can be extended up to infinity. So, y such that y is an element of real numbers. And it can be written also as interval notation, that is negative infinity up to positive infinity. Next, to further understand, let's have this example. So this is our x-axis and y-axis. Now let's find the domain of this graph. Notice that we have here a hollow. So for the x-axis, our minimum point here, our vertical, here is positive 1. So, but positive 1 is not included. So we're going to use the parentheses. So open to positive 1, and our last point, we have 4. 4. But it is shaded. So we're going to use bracket. Next, the range. For the range, our lowest point for the y-axis is -3, but it is hollow, so -3, and to the highest point we have +1. 1 is included, so that is bracket. That would be our domain and range. Another example. Okay, let's do another example here. What if I will use this graph. Let's say we have shaded part here. Then our graph will be like this one. It has an arrow. This arrow. Okay? So for our domain, we have here, for the x is -2, but -2 is included, shaded, so -2. We have here our arrow, so it will be extended up to infinity, so positive infinity. Then for the range, we have here for the y-axis, we have +1 included, so +1, and it will extend up to positive infinity. Okay. Last, let's say we have a graph like this one. Shaded, then shaded. Okay. In this case, for our domain, we have for the x, 2 is included, so 2, then 4 also included. And for the range, we have the lowest point, -3, then -2. That is the graph. Next, let us proceed to linear functions. Now let us proceed to example number 5, y is equal to 3x plus 2. We know that this is an example of a linear function. A linear function can be written in the form our function is written in the form y is equal to mx plus b, wherein b is our y-intercept and m is our slope. Okay. Now, in this case, we have our slope m, that is 3, and y-intercept, that is 2. If we're going to graph that, we have this form. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Y-intercept, +2, so +2. Then our slope, 3 over 1, because that is a whole number. So 1, 2, 3. So our point is 1, 2, 3, 4, 5, 1, 5. Now, if we're going to connect the 2 points, that would be our graph. Okay. Studying our graph, it will extend up to positive infinity and going to negative infinity. So for our linear function, if the given is a linear function, we have our domain, the negative infinity to positive infinity. And also for the range, that is negative infinity up to positive infinity. Because the graph of a linear function is a straight line, wherein it passes all our inputs in our x-axis and it passes all our outputs in the y-axis. Let's say we have given 2x plus 3y is equal to 6. First, we write it into our slope intercept form. Y is equal to mx plus b. So we have 3y is equal to negative 2x plus 6 divided by 3. Y is equal to negative 2 over 3x. 6 divided by 3 plus 2. If it will give you a polynomial, therefore our domain is negative infinity to positive infinity. And also the range negative infinity to positive infinity. You can write into set notation, that is x such that x is an element of real numbers, and for the range x such that x is an element of real numbers. Another example, last example, let's say we have 3 over 2x plus 4y is equal to 16. Okay? Let us check if this will give us a polynomial once we write it into linear or to the slope intercept form. So we have, okay, I need to remove the fractions, so I will multiply this by 2. So that will give 3x plus 8y is equal to 32. Now we have 8y is equal to negative 3x plus 32. Divide by 8, y is equal to negative 3 over 8x plus 32 divided by 8, 8, 16, 24, 32, that is 4. So it is a polynomial, yes. So our domain is x such that x is an element of real numbers. And for the range, x such that y, for the range y such that y is an element of real numbers. As simple as that for the linear function. Next, we have our quadratic functions. Let's say our example number 6, y is equal to x squared plus 2x minus 8. Before finding the domain and range, let us first graph this function. We know that in your grade 9 lesson, quadratic function, we have our vertex form, y is equal to a quantity x minus h raised to 2 plus k, wherein hk is the vertex. Let us find the vertex. Okay, we write it into vertex form. So that is y. Okay, let us isolate. First, x squared plus 2x, so it will become plus 8 is equal to x squared plus 2x. Move negative 8 to the left, and next step, make it a perfect square trinomial. So y plus 8 is equal to x squared plus 2x plus, to make it a perfect square trinomial, we must add a perfect number here. So to get that, get the middle term, 2 divided by 2, that is 1. 1 squared, then 1. We added 1 here, so we need to add 1 on the left side. Again, to make it a perfect square trinomial, get the middle term, which is 2, divided by 2, so that is 1. Then you square it, 1 square, 1 times 1 is 1. Now we have y plus 9 is equal to, we can write this one as a square of a binomial. So x plus square root of 1, that is 1. Then square. Then we write it into vertex form. Y is equal to x plus 1 square minus 9. This is now our vertex form, and we can get our vertex negative 1 and negative 9. That is our vertex. Locate in our Cartesian plane negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So negative 9, then negative 1. Okay, this is our vertex, our lowest point. Now, using our original given, we can get our x-intercept. So factor that out. X squared plus 2x minus 8. We can factor that out. Equate it to 0. I will write my solution here. X squared plus 2x minus 8. Equate it to 0. Then factor out. Factors of negative 8, the sum must be positive 2. So that is x plus 4, x minus 2. Because 4 times negative 2, that is negative 8. 4 minus 2, positive 2. Now we have x plus 4 is equal to 0, and x minus 2 is equal to 0. X is equal to negative 4, and x is equal to positive 3. Now locate on our x-axis, we have negative 4, negative 1, negative 2, negative 3, negative 4. Then we have x is equal to 2. This point. Now, connecting the 3 points, we know that quadratic function has a graph of parabola. It's either opening upward, downward, to the left, or to the right. In this case, our A is positive, so it opens upward. Okay, this will be our graph. To find the domain of quadratic function, we know that the graph passes through our x-axis up to infinity. So, negative infinity to positive infinity. And for the range, we have our lowest point, which is the negative 9, which is included. So, negative 9. Then, studying our y-axis, it will go up to positive infinity. So, domain, negative infinity to positive infinity, and our range, negative 9 to positive infinity. That is the quadratic functions. Next will be the rational functions. And now our last function, the rational function. Example number 7, y is equal to 1 over x minus 2 minus 1. Studying our problem, so rational function. We know that in our rational function, we have our ratio, a over b, and b must not be equal to 0. Or our denominator must not be equal to 0 because that will give us undefined. To find the domain and range of that, so domain, we can easily find the domain here, get our denominator, then equate it to 0. So in this case, we have x minus 2 is equal to 0. So x is equal to 2. That means for our domain, x such that x must not be equal to positive 2. Okay, that is our domain. So our shortcut here is solve for the value of x. Why x is not equal to positive 2? Because if x is 2, We're going to substitute 2 minus 2, that will give us 0. And now, to find the range, solve for x. So solve for x in our equation. So it will become, so our original equation is y is equal to 1 over x minus 2 minus 1. So y plus 1 is equal to 1 over x minus 2. Now cross multiply to remove the fraction x minus 2, or simply multiply the equation by x minus 2. So it will become y plus 1 times x minus 2 is equal to 1 over x minus 2 times x minus 2. That will be cancelled out 1. Now, divide by y plus 1. Y plus 1. So, the remaining here is x minus 2 is equal to 1 over y plus 1. Now we have x is equal to 1 over y plus 1 plus 2. Now, get our denominator, that is y plus 1, equated to 0. So y is equal to negative 1. For our range, y such that y must not be equal to negative 1. Because if y is negative 1, the function will give us a denominator of 0. And that gives us undefined. Next, last example. 3y plus xy is equal to 2x plus 1. Let us find first the domain. So, we need to equate the function. So, it will become get the common factor. So, common factor is y. So, we have 3 plus x is equal to 2x plus 1. And the common factor is y. So to check, y times 3, that is 3y. Then y times x, that is x1. We want y to be isolated. So divide by 3 plus x. So y is equal to 2x plus 1 all over 3 plus x. We can now get our domain. So our denominator is 3 plus x equated to 0. Now we have x is equal to negative. For the domain, x such that x must not be equal to negative. And for the range, we have our original given 3y plus xy is equal to 2x plus 1. Now, we have combined like terms, xy minus 2x is equal to 1 minus 3y. We need to combine like terms. We have x and x here, so moving to the left. So that will become xy minus 2x. Now get the common factor. In this case, we have our x. So y minus 2 is equal to 1 minus 3. Divide by y minus 2, y minus 2. So x is equal to 1 minus 3y all over y minus 2. Now, to get the range, get the denominator, y minus 2 equate to 0. So y is equal to 2. So for the range, y such that y is not equal to positive 2. Because if y is positive 2, that will give us 0 denominator. That is on how to find the domain and range. If the given are ordered pairs, mapping or arrow diagram, linear functions, quadratic function, and rational functions. Thank you for watching Senior Pablo TV.